Thank you. Thank you. Hi. How is everyone doing? I hope everyone is well. It's almost 4 o'clock Spanish time, official Spanish time for siesta. I am not going to make you do some exercises. I just want you to realize the week is almost finished. All of you have done a great job this week, so it's time for relax, to go out and to stop thinking and stop worrying about work. But before that, I want to tell you about building safer interfaces using TypeScript and a functional programming approach. This is not an advanced talk. I am not going to show you re-script or difficult operators or anything like that. Just to give you some context, I received the call to do the replacement for the talk on Monday. So I had almost no time to build this slide. I finished the slides yesterday night at 1 o'clock. So please don't be really bad for me. Okay, my name is Jose Manuel Lucas. I work at Freaky Company, and I know TypeScript and English to give a talk here. That's my resume. And I am going to tell you about functional programming and TypeScript. So if you are ready, I'm also ready. Let's go. The first thing I want you to know about functional programming is the concept of pure functions. What does mean a pure function? A pure function is a function that only depends on the inputs to produce the output and always produce the same result. So that means that it is deterministic, and we can trust that it will behave in the same way along the time. There is one exception to the inputs. You can use external constants, for instance, because they are not going to change along the time. So this is considered, or this is what it's called referential transparency, and that means that constant could be replaced by the value at any time, and it will produce the same result. One of the characteristics is that the arguments are never altered. So we don't mutate the inputs. And the most clear benefit is that they are easier to test. There is no need for mocks. Let's take an example of an impure function. As you can see, we have a function. It's called isOfficeTime, and it depends on a value that comes outside of the function. That value is current hour. We use just the common date API to retrieve the hours, and then we use that value inside of our function. But the problem is that without the context, we can't determine what's the value of these constants and how our function will behave. So how can we convert this to a pure function? It's really easy. You just have to pass the current hour, and then you have here what is called the side effects. So it is like your dirty code is outside of this function. You pass the current hour here, and then you obtain the value, and anytime you call that function, you can know in advance what will be the result. What does that mean? That means that we can test that function without having to worry about mocking the date object or anything. In fact, if we saw here, this is the line that will be outside of our test. And what's the meaning of testing that new date get hours produce what it is supposed to produce? If we can trust our language, then better we can leave the house. So the next concept is immutability, or the difference between a comparison by value and a comparison by reference. In JavaScript and, of course, TypeScript, arrays, objects, and functions are compared by reference. But the rest of data types are compared by value. So if we compare two numbers that are equal, the strict comparison, the 3 equals, will give us always true. If we build two objects, even if they have the same properties with the same values, they don't hold the same reference. So that means that if we do a strict comparison, it will return always false. If we wanted to do a real comparison, we will need to do a deep comparison. A deep comparison is usually imported from one library, or maybe you can build yourself. But the problem is that it's performance expensive. So if you do a strict comparison, it is really faster than a deep comparison. That doesn't mean that you never should do a deep comparison. You just know that it has a cost. If you are in the middle of nowhere, it is raining, you are tired, and you want to come back home, then you can call a cab, a taxi, and it will bring you, it will take you to your house, but that has a cost. So usually it's better to take a bus. That's the only thing I want you to know. So that's the reason why we don't do a deep comparison as the standard. We always do a strict comparison because it is way faster. When does a mutation happen? A mutation happens when a property of an array, of an object, is changed. But you don't change the reference. So let's take this example. I have an object with a unique property, which is called size. Then we assign the same reference to another constant, and we modify the original object, the property of the original object. The problem with that is that we have modified also the reference, the other constant. Many times that's not a problem, but what happens here if I forgot that I cloned that object and that I changed that object? There can be any inconsistencies there, so you have to be careful with that. The same happens for arrays. For instance, well-known methods as reverse. Just give me a second because I like to play with my hands, and I think I detached the microphone. Okay. For instance, everyone knows the reverse method. The reverse method is mutable, is destructive. So that means that when you run reverse, you are going to mutate the original array. So here I have declared a simple array of numbers. I run the reverse method, and I assign the result to a new constant. When I do a strict comparison, it tells me that it is the same. That's where I must be a little bit alerted. And if I print the original array values, I can see that it has mutated the values, and now it is on the reverse order. So again, if you want to do it, it's not a problem. But be careful when you do a reverse, because you can be changing the original array. If we want to prevent array mutations, we can do it just with the spread operator. So here, what we are doing is that we are creating an array, and we are using the spread operator to introduce all the items in this new reference. So if I do this, what I'm obtaining is a new reference, a new array. So this is acting like I expected. We have the original array, which is incremental, is ascending, and the reverse array, which is descending. Let's say we want to prevent object mutations. It is really easy. We can do it also with the spread operator. In this case, we want to generate a new house coming from apartment, and we want to have the same properties, but with a new size. We want to change the size. So what we do is just to use the spread operator. Many of you have used it before. We can also use the read-only TypeScript modifier. What we are doing here is to tell this interface that all the properties are required now, are non-mutable now, are read-only. OK, if we try to change a property, which is read-only, it will throw an exception, an error, sorry, at compilation time. So TypeScript is aware of this read-only operator. OK, the problem with functional programming many times, or with complex data structures, is that if we want to generate a new array or a new object, we must take into account that sub-properties are also mutable. So that means that if you change a property of an object which is inside of an object, and you only extended the first level, you are going to mutate the property. OK, so if we want to change here some internal properties, we must do, or we must run the spread operator at different levels. So here, what we are doing is we are taking the base apartment. We are replacing one of the dimensions to preserve the other properties. We are running the spread operator here, also with at a sub-level. And then we are extending the rooms array. What we do is to use the spread operator again. So we are introducing all the items in this array, and we are placing another item at the end, which is kitchen. There are some libraries like Immer that can help on simplifying the transformation. So for instance, what we can do is to isolate here also the side effects. You are going to listen me to say side effects many times. It's one of my favorite words, or two words, like Sergio Ramos said. So here we are using produce for immer. And what we are doing is we take the base data structure, in this case an object, and we obtain or we pass a function. This is a function which argument is the same data, but in draft mode. So that means that we can run side effects here, and we are not going to modify the original data. So instead of having to extend many times, to run a speed operator many times, we can just modify the dimensions width, or we can just push a new room. And after this function runs, we are going to obtain a new reference where we are going to leave the reference here for the original apartment. The next topic will be higher order functions. A higher order function, it sounds fancy. Many times, all these concepts comes from the mathematics world. So everyone that doesn't know anything about mathematics, like me, but is or likes functional programming, tends to say a lot of fancy words. So you can think that we can know a lot about functional programming, about mathematics, but in the end, the only thing a higher order function do is to receive or return a function. That's it. If we use the map method from an array, that's a higher order function. It receives an argument, which is a function. In this function, the argument is the item, which is passed, and the return is what the transformation we want to run. OK, an example, we could write, this is only for learning purposes. Please don't do that. We are going to create a simple replacement for try catch. It not only receives a function, but also returns a new function. So in this case, try catch, these are generics in TypeScript. It only means that it can hold any type of value at the given time. So we are declaring any function that receives any arguments and returns concrete value. And that function returns another function, this time with the current arguments, and returning the results. So we are wrapping inside a real try catch here, our call. If everything goes OK, we are going to obtain an object with a property which is success, that can be true or false. If it is true, it holds another property, which is called data. If not, it holds a property which is called error. So even if the result of the function explodes, we are safe here. For instance, we can declare a function which is called takeAge. TakeAge receives a person as an argument and returns the age property. We can protect this function. So we are going to have another function with the same signature. The only difference is that now we can pass unsafe data. Let's think, obviously, you are not going to do that in your code. But for instance, when you are calling Axios and you are passing a generic into the function, the only thing you are doing is to tell Axios, OK, you should treat the data like that in TypeScript. But you are not running any validation. So that means that even if your data is undefined, you can declare it as age number, as an object. If we call result, in this case, what we are going to receive is just an object with success false and a property called error, which will hold the real error, but wouldn't explode. For the second example, let's create a simple filter or paginator. OK, so what does this function do? The function makeFilter receives an object, an offset, which is a number, a limit, which is another number, a filter function, and a transform function. The filter function, as you may know, is the same type that you will pass to filter. So in this case, it receives any kind of type and returns a Boolean, meaning if that item must be preserved or not. For the transformation function, it receives an argument of any type and returns any other type. OK, so what we do here is that we calculate the filter items. For that items, we slice, so we obtain the paginated items. And after we have the paginated items, we transform the values. OK? Why doing something like that? Because you can create some kind of generic filter that you can reuse across your pages. So for instance, in the case of the home page filter, I want to return from offset 0 to 12. And I want to filter the items with a property, with a flag. And then I want to transform these properties so I can only return the ones I'm interested on. How should it work? OK, we can call a service that will return an array, a data. And then we can build the real data coming from our raw data. And we can assign it. The next term is encapsulation. For instance, one of the dangers of using private in TypeScript is that it gives you a false illusion of safety. So for instance, we are declaring as private name, surname, and money. What happens if I tell you that this is possible even in TypeScript? So I can declare money as private, but if I use the bracket access instead of the dot way of accessing properties, I can modify the money. So for instance, I could say that I want 1 million euros. The solution could be using private fields. Okay, private fields are defined with this symbol. And even in runtime, this is protecting you with a weak map of accessing these properties. What if I tell you that you can do it with a simple function? So this is the equivalent. You pass the name, the surname, the money, and you are returning just two methods, two properties that are functions. So you cannot access name, you cannot access surname or money once you have declared your object, but you can retrieve the full name or the money. The same done in the previous slide. OK, composition. OK. In object-oriented programming, you can use the extends to extend from another class. So you can use both properties here, and it will behave like expected. In functional programming, you can run just composition. So you can have a function which only returns a name. And using that function and the split operator, you can create a new type of data. For instance, an employee, which is a person, so you can have access to the name, but also you are defining here the position, and it will behave in the same way. Okay, let's say we have a list of owners and their houses, and we want to sort the owners by the total area of their houses. And also, for each owner, we want to sort their houses by area. We could do it using a lot of functions, as you may see here. I am going really fast because the time is expiring. But I want you to know about a library which is called FPTS by Julio Canti. If you have used Randa or Lodash FP in the past, it is more or less similar. Obviously, it needs to deal with TypeScript, which is a little bit complicated. But this is the code that I will write for a solution like this. So if you compare the two versions, you can see that it is much more readable. What we are doing here is we are declaring a function to retrieve the get area for a house. It just a multiplication, a product from two properties. To get the total area, I have also a function which is running reduce. And then here comes the magic. Everything here are operators from FPTS. The first one, contramap, it's running this function with this one. So what we are doing is to build ordering, a number ordering, and then we use the reverse operator to tell, OK, but it is on descending order. We do that for both properties. We could have even improved this by creating a generic function that will retrieve, that will get the real function as argument, and we'll use it here, but for the moment it's OK. Then we create the real sort functions. You can use different way of sorting. So for instance, you can tell first sort by this property, descending, then by this one. And we are running here also the eval, which transform the properties of an object by the function which is provided. And then the last thing I want you to know is the pipe operator. Pipe operator takes first the data you want to transform, then it passes the data to this function, it runs the function, and the result of that function will come here as the input for the next one, until all the functions in the pipe are finished. So you can have like a flow, a real flow of what's happening in your transformation. I don't have more time, but if you want to talk about functional programming, about TypeScript, about anything, I'm on Twitter. I don't know if people still use Twitter, if it is still alive, but you can find me on Twitter. I am JML Those are my initials. Thank you for coming. I hope you are not asleep. Thank you. Thank you.